Hello, this is Michelle Hobbs, and I am about to take the exam one. Oh, let me share my screen. Share. Okay, great. Excuse me. Okay, I'm going to go ahead and click on this. Okay. Question number one, I affirm I will not give or receive any unauthorized help on this exam and that all work will be my own. I affirm that I am not using any AI tools to answer these questions. I pledge not to share or discuss any of the exam questions or contents on any websites, apps, or other platforms. Let me write my name. Okay, next. Okay, let's see here. Question two, determine whether the numerical value describes a population parameter or a sample statistic. The freshman class at a university has an average SAT math score of 514. I do have my handwritten notes here that I will be referring to. Okay, so which I'll upload as well. Let's see here. So sample, let's see. The freshman class at a university has an average. So the freshman class and then population. I'm going to say all for population, surveyed for sample. The freshman class. I'm not seeing any of the key words that I wrote down here. So for a population, we look for all. And then for a sample, we look for like surveyed. Um, let's see. I'm going to say that the answer for this one is actually none, because it says the freshman class at a university, but it doesn't say the freshman class at a university, the age of every. I'm just looking at my example from the practice exams. Sample, we don't count every person. Population, we count every, each and all. Yeah, I'm gonna say none because it's not really describing every person. It's not really describing like all. And it's not like giving us like a survey. It's just kind of giving us a fact. So has an average math score. Yeah, and it's like very vague. It's not saying like what university. It's not really giving us like an exact amount. And it's not like saying it's a survey either, so I'm gonna go with none. Okay. Determine if the study, excuse me, represents the descriptive branch of statistics or inferential statistics. Um, the descriptive branch or the inferential. So inferential is future and descriptive is about current. Um, so let's see. In a sample of Wall Street analysts, the percentage who incorrectly forecasted high-tech earnings in a recent year was 44. So inferential is future, descriptive is current. And this is saying High-tech earnings in a recent year. So this is neither future nor current. So I'm gonna go with none for this because it's talking about a past. Okay, excuse me. Okay, so we're looking at this data here, and we're gonna first find the class width. So let me see my notes. Class width is the difference between these numbers here. Let me just make double sure that that's correct. Yeah, so the difference between 31 and 20 is 11. And then the difference of 42 and 31 is 11. So our class width is 11. And then finding the midpoint. The midpoint is the lower class plus the upper class divided by 2. So midpoint of the first class, 20 and 30. So it's going to be 30 minus 20. Let me see here. 30, look at my notes, sorry. So it's going to be, so lower and upper. Lower is 20, upper is 30. We add those together, sorry. So 30 plus 20 is 50. And then we divide 50 by 2. So that's going to be 25. How much data do we have in the collection? How much data do we have in the collection? So I think that's when we add up all of these numbers here. So 10, 20, 30, 40, 50, 60, 70. I'm guessing on that. And then the relative frequency. Oh, class width, and then the relative frequency is gonna be oh yeah. So the relative frequency is gonna be all of those class numbers over here. Sorry, I'm pointing at the screen like you can see. All of those class numbers. And we're gonna figure out the difference between them. So 20 minus 30 is 10. And then 31 minus 41 is 10. So the number is going to be, oh, relative frequency of the first class. The range. Oh, relative frequency is gonna be the frequency number divided by, so the first class, right? Let me see here. 1, 2, 2, 3. Sorry, I'm just looking at my notes and comparing. So, the relative frequency, oh yeah, that's a decimal. So it's gonna be, sorry, of the first class, 19. divided by how many classes there are. So 1, 2, 3, 4, 5, 6, 7. So 19 divided by 7. Let's see, because we did, hold on a minute. 3. Hmm. Oh. Oh, okay. So hold on, sorry. I think it's all of these numbers added up. So 19 plus 43 plus 68 plus 69 plus 74 plus 68 plus 24 equals 365. So it's going to be 19 divided by 365. I hope this is right. Point 52. I'm just gonna go with that. On to the next. Okay, so let's see here. The number of classes is employee salaries. Um, let's go back to class with. All right, let's see. Salary, frequency, and number of classes. I believe the number of classes is the column. So 1, 2, 3, 4, 5, 6, 7. Um, yeah, okay. And then the class width again is going to be the difference between the classes. So right here, we have 24.5, 34.5, 34.5, 44.5. So that is looking like 10. I'm weird and I have to like make sure my calculations are right, even though it's really obvious. So the class width is 10. And then the center approximately is 55. So the center, the center. Um, the center, let's see, I would say it's about 44. This diagram is actually pretty symmetric. So I would say the center is about right here, which is approximately 55 because it's right here on the 54.5 mark. So I'm going to say true. 6, okay. The mileage is in thousands of miles for a rental car's company fleet. So we're looking for the range. I have to like handwrite this out to calculate it. Looking for the range, looking for the range. How to find the range? Okay. So to find the range, we find the highest data set and then the lowest data set. So with these numbers listed here, we've got, it looks like the highest is going to be 15. Let me just double make sure of that. 15. And then it looks like the lowest is 2. So we take the highest, 15, and then we take the lowest, which is 2, excuse me. And then that is going to be the answer. So let me just double make sure. So 15 definitely looks like the highest and 2 looks like the lowest. So 15 minus 2, so 15, 14, 13. And then use the calculator to find, use your calculator to find the population standard deviation. So standard deviation, this one I might get a little stuck on. Let's see here, use your calculator. Um, which I have in my phone. Calculator to find the, let's see here. Just looking up this formula for the calculator. Okay. I took a snapshot of all of that. So, wait a minute. Low value. Okay, so to calculate the population standard deviation, I am going to enter all of the numbers. And the number I am getting here is standard deviation. Enter all of those numbers. Four, three, 6, 8, 1, 4, 14, 12, 3, and 3. Okay. So the sum, I'm just trying to read the calculator correctly. So approximately round to 1 decimal, I'm getting 4.708. So I'm going to put 4.7 if I'm reading it correctly. Make sure I entered all the numbers 9, 12, 3, 6, 8, 1, 4, 14, 12, 3, 3. Sometimes I don't enter it right. Okay. All right, let's see. You need to purchase a battery for your car. There are 2 types available. Type A has a mean life of 5 years and a standard deviation of 1 year. Type B has a mean life of 5 years and a standard deviation of 1 month. Both batteries cost the same. Which one should you purchase? Which one should you purchase if you are concerned that your car will always start? Um, type A has a mean life of 5 years. Type B has a mean life. Type B has a mean life of 5 years and a standard deviation of 1 month. Um, mean life. Sorry, while I think about this. Less variation. I think I feel like um mean life of and then standard deviation. That makes me like 5 years. 1 month. 1 year, 1 month. Um, I'm trying to decipher if, okay, standard deviation. And then which one should you purchase if you are concerned that your car will start? Um, all right, so they both, sorry, I'm a little stuck on this one. They both have a mean life of 5 years. And choosing between the two products of that, I think the standard deviation of one has a 1 year and then one has a 1 month. I think it's like a trick question because I wanted to think 1 year because it's longer than 1 month, but I think that you would actually choose 1 month. Um, but I don't know if it's less. Battery B, less variation or more variation? Less variation. Less variation, I think. Oh, okay, so the standard deviation is how spread out the data points are from the actual mean. The standard deviation um so I think when you've got a smaller standard deviation, then the data points are going to have a greater consistency. So I want to do type B, but I'm trying to think if the wording is right or not. Okay, so the smaller the standard deviation, the data points are going to be closer to the value if you're thinking of it in that way, which has a bigger consistency. So B has a mean life, 1 month. So it would be B, and it would be because it has, I think because it has less variation. I think that's right. I don't know. Hoping so. That was kind of tricky. Okay. You are the maintenance engineer for a local high school. You must purchase fluorescent light bulbs for the classroom. Okay. Should you choose type A? Oh, goodness. Okay. The bulbs, let me think. 3,000 hours and 200 hours. 3,000 hours and 250 hours. The bulbs with the lower standard deviation are more consistent. Lower standard is more consistent. Both have the same probability. Um, 3,000 hours, 250 hours. So the bulbs with the, I think again, because the lower the deviation, the more consistency. So I think it's gonna be oh okay, so I think let me think here. 3,000 hours, 3,000 hours. Um the bulbs with the lower standard deviation are going to be more consistent and it is easier to plan for their replacement. The bulbs with the higher deviation. So I think um they're like really close, so that's why I'm getting confused here. Uh, the lower. Okay, I'm just gonna go with this one because that's how I'm feeling like because the lower the standard deviation, the more consistent. Um, because like the standard deviation again represents how like spread out like the data points are from the mean if we're thinking about it in that way. And then the smaller deviation means that there's greater consistency because the data points are more like clustered. So I'm gonna go with that. Hoping that's right. Okay. Oh, that's all. Okay. Now I finish recording the session and upload the link on Google Drive or Canvas Studio and share the links in the next assignment. Please note that you can retake the exam, but make sure to re-record your session and submit the second recording as well as the first recording. I'm going to say true to that. And here's good luck to me. Thank you. I will stop it. And then if I have to retake it, I will. So, yes, I don't know how to stop this recording though. Oh, oh, stop share first. Okay. And then stop. Thank you.